Alright, welcome back. I decided to go with these MOSFETs. These are the P75 and F75. And the reason I'm going with these over the other ones I was looking at, where are they? I don't even know where they are anymore, is because the other MOSFETs had an RDS on of 0.33 ohms. These have an RDS on of 0.01 ohms, so it's many times better, and I think that'll be more important for doing low voltage loads. Now I'm just trying to figure out, I want to use this heatsink, this thermocore, but I'm just trying to figure out how to attach 16 transistors to this to the back side of this heatsink. And I was thinking, they got the big bolt hole in the middle here. I was thinking maybe arranging 8 transistors on each side of the bolt hole. Something like this maybe, I don't know. Each channel is going to have 4 transistors. And then I need to bolt these down somehow. And I was thinking get a steel plate and maybe putting a slight curve in it so that it has a little bit of spring, so that the outside ones get pushed down as well as the inside ones when I tighten it up. I torque it down. I don't know yet. I was thinking maybe using a block of wood to actually, well, a block of rubber would be better. It would put pressure, downward pressure on all 16 transistors while I suck down the center bolt. I really can't drill anything into this because it's a thermocore. It's like a heat pipe, and it has once you puncture it, it's no good anymore. I'm thinking something like that. And of course I'll have to use a silly pad to insulate these from the copper. I'll try that. I think that's going to be the only way to do it without building something else. I have these 4 holes I could use, but then I also have to use some of these holes for mounting. Like this hole here I need to mount, and I was thinking using one of these 2 holes as a mount to the case, to the cabinet. But I was also thinking putting 4 here, 4 here. That's not going to do any good to me. Yeah, I think I'll have to go with this way. And if I can find something that's rubber or even wood that I can use to put over here so that when I snug down that center bolt, it puts pressure on all 16 transistors and there's no loose ones, no air gaps. Okay, I'll think about that, and then I'll see what I can do. And then this will work good for my heatsink. I put fan on one side. It won't be pretty, but it'll work great. Okay. On to the power supply. So for the power supply, I decided to make one mod. I removed this 120 microfarad 400 volt cap, and I replaced it with a 200 volt 220 microfarad cap, and it's a stubby one, so it's going to sit lower profile than the original. And this was failing anyway, so out it goes. And I checked these 2 caps; they're good. These 2 caps, I'm only going to be using. There's actually two outputs on this power supply, and I checked with the voltmeter. One outputs something like 11 volts, and one outputs 7.5 volts. The higher voltage one is this, for this cap here, and it's a 50 volt 150 microfarad. I was thinking of upgrading this cap, but I think, why the hell should I? Because every board here has a 1000 microfarad caps. So there's 2000, 4, 6, 8000 microfarad caps distributed along these boards. So I don't think I need another one here. But I was looking at where to mount it. If the heatsink is in the center, like this, I was trying to think of where I could mount the power supply. Can't put it here because there's going to be a fan. There's going to be a hole cut here for a fan on the right side. Didn't really want to put it here underneath these wires. I think best was I was going to mount it on the back here, right there. I was going to put on a couple of standoffs. Now, gotta remember this is upside down. This is actually the bottom. So I want the heatsink on top. Heat flows up, so that's mounted correctly. Actually, in service, it'll be sitting like this, and the heat won't be affecting the cap. But for right now, I was going to mount this. Actually, you know what? I can't mount it until I do my wiring. There's a couple standoffs from the insulated standoffs, and then I cut an insulated sheet. Is this the right way? Yeah, this is the right way. So there's an insulated sheet here to protect it from the chassis, not grounding. And then that'll just snap in there on those two standoffs. And that'll hold it there. Now I need to do wiring. I have to wire in the power. I have a power wired here, fuse and switch. So I'll wire that in, and then I can mount that. And then it's just a matter of hooking things up. I need to figure out this heatsink though. I'm gonna put the camera on pause and put my thinking cap on and what I can do with it. Okay, I think I'm gonna change my mind one more time here. I'm not gonna go with this heatsink. I'm gonna go with this copper one. I think I have enough surface area to drill and tap 16 holes. And I just need to remove this bracket that's soldered in. I can just heat it with a torch, take it off, and then I'll use this. This will be big enough, I think, to just dissipate all the heat I need. Yeah, I think it's going to work. I got a lot of these, so I'll just use one of these up. And yeah, we'll go with that. I'll have to drill and tap some holes. But that'll leave me with a lot of free space inside the cabinet. This one, nope. Actually, they're pretty much the same height, so it should work. And then I can have two fans blowing or sucking air through, and I can have probably a 40mm fan. I think I have some here. Alright, so I had to take the torch and heat up this bracket to remove it. It was soldered onto these fins. But yeah, it had to get pretty hot. And it got so hot, in fact, that look at how it bulged up. So I think I have a core in this one as well. Let me dig a bit and see. I think there's probably a fill pipe here or something. Let me try. Seems like this thing is sealed off. I don't know if I can get this out as epoxy. Yeah, I don't know. So I'm glad that didn't burst on me, because that was quite a bit of pressure when I'm going to put the heat to it. One of two things, I could still use it, but I can't drill holes into this centerpiece here, because I think it's got a heat pipe core. I could probably drill mounting holes along the outside, but I can't drill anything here. Oh boy. So I dug out a couple of these fans. These are 40 millimeters, and they are removed. Well, actually, hang on here. They're DC 12 volts, 0.6 amps. Sanyo Denke. These are out of server power supplies, and small size, pack a lot of power. Here, I'll put it 6 volts to it. You see, with 6 volts, it's really got a lot of flow. I'll put 12. And it just wants to take off. Might be a little overkill for what I need. Okay, so this is about the best what I can come up with at the moment. A copper heatsink with fins that go this way. So all my airflow will go from front to back. The two fans will get located on the back face, approximately right there. I'll cut holes for those two fans and drill for mounting, and then I'll mount this lump of copper directly in front of those two fans, and I'll have to put standoffs and posts here to mount this on, because it's quite heavy. You don't want it moving around. And that will take care of my thermal, getting rid of the heat. Now, this heatsink doesn't afford me much room. It does, from what I can determine, it does have a thermal core in it, and the thermal core is quite a large area, so I can't drill into the middle of this, otherwise I'll puncture it. So what I'm thinking of doing is drilling my mounting holes along the outside, close to the edge. Of course, I'll be using sill pads and everything to insulate these. But what I might have to do is I might have to put 8 transistors on one side, 8 transistors on the other. Let's see if we have room for that even. Let's mock this up. Some MOSFETs here. Mock up with the MOSFETs. Got 3. Now I know it's going to look like hell with all the wiring, but once I put the cover on, I'll never see it again. And the only time I would have to open it is to service this thing, and hopefully it'll never break down on me. Okay, so I got 6. 7, 8 on that side. And then we'll try 8 for this other side. The thing is, not all 4 channels are ever going to be used at the same time, unless I get into a situation where I got a computer power supply and I want to test 3 channels, maybe 4 channels. So let's see how this all stacks up. Might have to do some careful drilling here. I got some lines scribed on the outsides from where I figure that I can drill holes safely. I can move these closer together. And I kind of run out of room right here on this little divot. These two are okay. I can fit one here. What do you think? It's going to be a rat's nest. The wiring's going to look horrible. Every transistor's got 3 wires. What I could do is, I don't like this too much, so what I'm going to do is I'm going to do this. I think this is the best way to do it. And maybe this. Yeah, it's going to have to fit there. I got enough room for 4 transistors here. I think this is the best way. It's just going to be a rat's nest in the middle there with wires. But let's go for this. Okay, I'll space these better and mark out locations for the holes, the drilling, and we'll go with that. And for right now, I can mark these 2 for the fans, and I'll drill all those holes from the back panel. Let's see if I have something here I can mark it with. Okay. The other thing I want to mark is okay, that's my locating for the drill some holes and we'll be done. Alright, so I got the holes cut in the back for the fans. Let's see here. This fan is going to blow this way, and this fan is going to blow this way. So those holes are cut, they can be mounted. I was just going over the pulse width modulation of this fan controller, and it uses all 4 wires, which isn't a problem. You got your plus minus, your black and white, or black and red, sorry, and then one of these wires is a feedback, and another of the wires, I think the blue, is your pulse width modulation that modulates the fan speed. So I just need to figure out which pin goes on which wire, and that should be simple enough. This fan is different wiring altogether. It's got brown and yellow instead of white and blue. So we'll figure that out. That's not a big deal. There's a very good web page for this HW585 fan controller, and it goes over all the settings what these toggle switches do. This one's set at 20% to 100%, and then you can set these two to run as little as 10% using these two pots. And then with the 5 toggle switches, you can configure how it works, and it's pretty simple. I'll put a link in the bottom of the page here to this website that the guy's talking about this, and it's quite helpful. So yeah, I think everything's ready to go with this mounted. Fans are cut, ready to go. I got the mounting holes for the heatsink, and I'm going to use some standoffs. Some long standoffs. This is sized for the heatsink, and these are 45 millimeters. So there's going to be 4 of those for the heatsink. Next step, I guess, is get these MOSFETs prepared and get this thing drilled. I hope this doesn't give me any troubles. I intend to drill about 4 millimeters away from the edge, so that should give me enough room to bite in with a screw, and should keep me far enough away from the core so I don't damage the core. Alright, so change of plans. I was going around drilling the holes for the mounting the MOSFETs, and then I got to this side and it went kind of funny, and with that, let's see if I can find it. I was looking at it and I drove a hole right into the core. So you can get this right in there. This one too. So I drilled another hole. Yep, same thing. So I punctured the core in this, the thermic core, and it's basically scrap metal now. Which is okay. I have more of these, but I'd have to remove this bracket here with the torch. The thing is, this isn't ideal, so I got thinking about this again. So let's get rid of this and this, and let's go with this. Here's a copper heatsink. It's different size, and I think we can make it work. Let's try this. The only problem is with this heatsink is I don't have any mounting options. It's just pretty much a rectangle with no holes in it. But I'm kind of annoyed with this because I spent so much time getting these holes just right. Look at those holes in the back for the fans, and now it's all for nothing. But let's see. We can do this. And we can do this, and we can get we can now upsize our fans to, what is it, 60 millimeters? See, fits a 60 millimeter perfect. And all I have to do now is redo my holes. I'll split these apart. And let's see. Out of the way. So that's pretty much what it's going to be. It's going to be awfully heavy. A lot of copper there, but I think that's the direction we're going to go with this, because the other heatsink won't work. And I do have, how much room do I have here? I got enough room to put the MOSFETs in. Let's see here, let's find one. And it won't touch the bottom cover. I'll have to put 8 transistors on each heatsink. But it's no problem drilling this because these are not thermocores. These are just straight solid core heatsinks, copper heatsinks. I could use aluminum too, but I really don't have any aluminum in this factor. There we go. That's what it's going to be. So let's work for that. Okay, so I think I got it done. I butchered holes bigger for the fans. These fans will be going mounted like this. And you go like this. I might not use these fans. The leads are a little short, so I might find some with longer leads. That's going to be that. And I've drilled the heat sinks for 8 transistors and 2 mounting holes. And they'll go like this. And I'll have to mount these. I need to locate and drill a hole. This standoff will be mounted on the bottom like that, and then a screw will go down from the top and secure it down. It's not the ideal. I'm only going to have 2 posts for each heatsink. These are quite heavy, and you know, if this thing got knocked around or dropped, that would not hold these heat sinks in place, but we're going to go with it anyway. I still have to bevel the edges of this. I'll need like a drill bit just to go like this and put a little bevel on there so that the doesn't cut through the sill pad. Okay, so just assembly now, mechanical assembly. I'll put these together. Need to dig out some hardware for that, and I'll locate and drill those holes and get these heat sinks mounted. I drilled these holes 2.6 millimeters approximately, and they'll work. What I'm going to use to secure them down is just a self-tapping screw. Let's see if I can find one here. Right here is one. Self-tapping. Just want to see how they bite. Oh yeah, that's good. That's going to be really good. So I'll get sill pads, shoulder washers. I'm going to need to find a bunch of these self-tapping screws. And then we're done, pretty much. Then we start on the wiring. One thing I forgot to mention, now that I have 2 heat sinks and they're independent of each other, I'm going to need another fan controller to control the heat sink. So I'll have one fan controller on one fan controller on another, and just one fan on each system, and they'll work independently depending on because I'll have 2 channels on this one, 2 channels on this one. Obviously, if I'm not using this channel, it'll always stay cold and it won't kick on. But yeah, it's looking up. I'm looking at these fans. These are a little better, I think. Nidec Beta 5s. These are 12 volt, 1.5 amp. What? This one here is 12 volts, 1.8 amps. I mean, it's not the same fans. I'll get a pair that match. Anyways, I'm going to continue with the mechanical assembly, and then we'll catch up again with another installment or update on the electronic load project. once I get everything mechanically fixed, and then I start doing the wiring, and then we can go on to testing and wiring, testing, and alignment. Gotta align all these voltmeters, and we'll try it out, see how it goes. So stay tuned. Thanks for watching.